now let's learn about load balancing. And a question you may have is, what is load balancing? Well, a load balancer is going to be a server or a set of servers that will forward traffic that is received to multiple backend or downstream EC2 instances or servers. So the idea is that, for example, we have 3 EC2 instances, and they're going to be fronted by an elastic load balancer, which is a set of servers behind the scenes. Now, what happens is that when you have, for example, 3 users directly connecting into your elastic load balancer, well, the first one is going to have its load being sent in one backend EC2 instance. And because there's load balancing, well, if another user is connecting to your elastic load balancer, then it will be sent to another EC2 instance. And then finally, well, if a third user is connecting to your elastic load balancer, that user will again be load balanced and sent to the third EC2 instance. So the idea is that the more users you have, the more the load is going to be balanced across EC2 instances. But the idea is that your users do not know which backend instances are connected to. They just know that they have to connect to your elastic load balancer, which gives them one endpoint of connectivity only. Now, why should you use a load balancer? Where you're going to spread the load across multiple downstream instances. You're going to expose a single point of access to your application, as I just said. You're going to seamlessly handle failures of downstream instances because the load balancer will have some health check mechanisms and can understand to which instances it cannot send traffic to. You can do health checks on your instances. You can provide SSL termination, so to have HTTPS encrypted traffic for your websites. You can enforce stickiness with cookies, high availability across zones, and separate public traffic from private traffic on your cloud. And we'll explore these concepts, obviously, in a deeper dive. So the Elastic Load Balancer is a managed load balancer. As such, AWS will be managing it, and it guarantees that it will be working no matter what. AWS will take care of upgrades, maintenance, and high availability, and it will provide you a few configuration knobs to tweak the behavior of the load balancer. The idea is that using an elastic load balancer is a no-brainer because it will cost you less than setting up your own load balancer. And also, if you had to manage your own load balancer, it will be a nightmare from a scalability perspective. So also, the load balancer is integrated with so many AWS offerings and services. The idea is that it can be integrated with, of course, EC2 instances, but also we'll see later on auto-scaling groups, Amazon ECS, Certificate Manager, CloudWatch, Route 53, WAF, Global Accelerator, and most likely more over time. So the idea is that the load balancer is a no-brainer when it comes to load balancing on AWS. Now, I mentioned health checks. So health checks is a way for your Elastic Load Balancer to verify whether or not an EC2 instance is properly working. Because if it's not working properly, then we don't want to send any traffic to that instance. So they're crucial for load balancers, and they are done by using a port and a route to check the health on. So for example, in this example, I have the protocol being HTTP, the port being 4567, and the endpoint to be /health, because maybe this route is an easy way from an application perspective to check the health of my application. And if the EC2 instance does not respond with an OK response, which is usually the 200 status code of HTTP, then the instance will be marked as unhealthy, and the Elastic Load Balancer will not send traffic to that instance. Okay, so now you have 4 kinds of managed load balancers on AWS. You have the classic load balancer, which are called older generation or V1, which is from 2009, and it's called CLB. Now it's compatible with HTTP, HTTPS, TCP, SSL, or secure TCP. And overall, AWS does not want you to use that load balancer anymore, so it's going to be shown as deprecated within the console, but still available to use. Then we have newer generations load balancers. So we have the application load balancer from 2016, also called ELB, and this one supports HTTP, HTTPS, and WebSocket protocol. Then we have the network load balancer from 2017, which supports the TCP, TLS, the secure TCP, and UDP protocols. And then finally, we have the Gateway Load Balancer from 2020, GWLB, which operates at the network layer, so layer 3, and the IP protocol. So overall, it is definitely recommended for you to use the newer generation load balancers as they provide more features. And some load balancers can be set up as internal, so private and private access for the network, or external public load balancers, for example, for your websites and public applications. Finally, you need to understand the security around load balancers. So the users can access your load balancer from anywhere using HTTP or HTTPS, and therefore the security group rule is going to look like something like this, where the port range is going to be 80 or 443, and the source is going to be 0.0.0.0/0, which means anywhere. And so we allow the users to connect to our load balancer. But then the cool thing is that the EC2 instances should only allow traffic coming directly from the load balancer. And therefore, the security group rule of your EC2 instances is going to look a little bit different. So it's going to allow HTTP traffic on port 80, and the source of it is not going to be an IP range, it's going to be a security group. So we're going to link the security group of the EC2 instance to the security group of the load balancer. And effectively, what this will do is that it will say that the EC2 instance is only allowing traffic if the traffic originates from the load balancer, which is an enhanced security mechanism. So that's it for the overview of load balancers. I hope you liked it. And obviously in this section, we're going to discuss a lot more around classic application load balancers and network load balancers. So I will see you in the next lecture.